I've got two integrals on the board here, both definite integrals, that have the same denominator, square root of 1 plus x squared. And I want to just take a look because neither one of them is set up perfectly for a u sub, but one of them we're going to be able to deal with, and one of them we're not this semester. Okay. So, for both of these, I think if I were to do a u sub, I would let u equal 1 plus x squared. That's the quantity that's inside that square root. Now, you might think, well, shouldn't I just choose it to be the square root of 1 plus x squared? Would that perhaps be a better choice? I'm thinking not, just because I know if I take the derivative of this, the derivative is going to involve a square root in the denominator, and I don't have another square root floating around. So I think I want to keep it a little bit simpler. If I just go with 1 plus x squared as my u, that's the square root of u on the bottom, or u to the negative 1/2. So I'm going to try that, but if this is going to work, my u prime would be 2x, so that du would be 2x dx. Now, for both of these, I'm missing the 2. For both of them, that's very easy to deal with. I can simply multiply by 2 on the inside and counterbalance with a 1/2 on the outside, and then we're fine. But the difference is, here, I'm also missing the x. I don't have the x that I need for my du. Here I do have the x, but I have too much, because I have 3 factors of x on top, and I only need one of them for the du. So for this one, I'm going to just try rewriting a little bit. Integral from 0 to root 3. I'm going to rewrite that top as 2x times x squared over root 1 plus x squared dx. So that this part I would need to get absorbed into the du, but this is what I would call an extra factor. As a general rule, if I'm doing u subs, I've found that it's usually easier to have too much than to have too little. Okay. Here, I'm missing an x. Now, it would be legal for me to multiply by 1 in the form of x over x. So I could introduce an x on the top, but I'd have to also introduce an x on the bottom. Now, that's similar to what I did with the 2, but the difference is that the 2 was constant, so I could factor out that 1/2. I can't factor out the 1 over x here. I can't pull a variable outside of, sorry, that's from 1 to 2 still. I can't pull a variable outside of the integral. Okay. So while now I've got what I need for the du, now I've got this extra piece that is kind of tricky. Here I have an extra piece as well. I like this extra piece better. And here's why. Look at what u was. U was 1 plus x squared. X squared shows up in that. So I could solve for x squared. It's going to be u minus 1. Okay. Here, I have an extra factor of x. Now, I could try to solve for that, particularly because since this is a definite integral, I know that x is not negative because I'm integrating over an interval where it's always positive. So I could say that x is the square root of u minus 1, but I think that's going to be more complicated. When I have an extra piece and it shows up in the formula that I have for u, that's a lot more hopeful. So for this problem, I'm just going to say our u sub does not work. Now, it does turn out, but I had to look this up, that what I had was the derivative of the inverse hyperbolic sinh. So if you happen to know that the derivative of inverse hyperbolic sinh is 1 over root 1 plus x squared, you could do that integral. I do not think it is worth memorizing the derivatives of the inverse hyperbolic trig functions, and I have said you won't get any credit for having them memorized. This semester, this is just a problem that we're not going to be able to do. Next semester, you're going to learn a technique called trig substitution that will allow you to do this without having to memorize the derivatives of the inverse hyperbolic trig functions, because too much memorization just not going to be helpful. Okay, so this is a problem that at least this semester we're just going to say, nope, we can't do that. We were missing the variable part, And while it's legal to multiply by 1 in the form of what we were missing over at self, so the x over the x, once I did that, it made things more complicated so that I wasn't able to do the u sub. Worth checking, but it didn't work. This one, however, I'm going to try to rewrite in terms of u. So I'm going to say we've got 1/3. We're going to be integrating from the u value at 0, which would be 1 plus 0 squared is 1, to the u value at root 3. 1 plus root 3 squared is going to be 1 plus 3 is 4. Now we said the 2x and the dx are going to become du. X squared is going to become u minus 1. And root 1 plus x squared is root u, or u to the 1/2. Okay. So at first glance, it might look like, well, this isn't just a simple function that I can integrate, but we can now do this, because here's the difference. Here, I had a division problem, because a fraction is a division problem, but the top was a power of x, and the bottom was a power of 1 plus x squared, because it was 1 plus x squared to the 1/2. So I could write things as powers, but they were powers of different bases. Now, by doing this u substitution, all of my variable powers are powers of the same base u. Now, what that means is I can simplify the arithmetic. So it's not in shape for me to integrate as is, but I can do the division. This is u over u to the 1/2 minus 1 over u to the 1/2 du. Division distributes over this subtraction. And now I can simplify and write each piece as just a simple power of u. This is u to the first divided by u to the 1/2 is going to be u to the 1/2 minus u to the negative 1/2. And we're integrating that with respect to u. Okay. So there's a little bit more work to do, because I do need to remember I don't, with the exception of a u substitution, I don't have a rule for dealing with multiplication and division, but sometimes I can do the multiplication and division, and that's what we were able to do here. So now let's just take our antiderivative. So I'm going to have 1/3. This is going to be 2/3 u to the 3/2 minus 2 u to the 1/2, and that's evaluated between 4 and 1. So that's 1/3 times 2/3 4 to the 3/2 minus 2 times 4 to the 1/2 minus what I get at 1. Lovely thing about 1 is that 1 to any power is just 1. So this is going to just become 2/3 times 1 minus 2 times 1. Now, here's my rule for simplifying fractional powers like this. Okay. The 2 on the bottom tells me what root to take. The 3 on the top tells me what power to take. If the root part simplifies nicely, I expect you to simplify things. So the square root of 4, yeah, that's nice. Square root of 4 is just 2. 2 cubed would be 8. So this is 1/3 of. This is going to be 2/3 times 8 minus 2 times 4 to the 1/2 is just the square root of 4. That's 2. 2 times 2 I'm going to go ahead and do. That's going to be just 4. Whoops, 4. I'm going to go ahead and just distribute this negative. Minus 2/3 and then plus 2. Okay, so that's 1/3 of. This will be 16/3. I think I'm just going to get a common denominator of thirds here. So minus 12/3 minus 2/3 plus 6/3. So that's 1/3 of some thirds. 16 minus 12 is 4, minus 2 is 2, plus 6 is 8. So that would be all of 8/9.